Doesn't seem to be on. Hello, everybody. Sorry for the delay. Hopefully you can all hear us now. So welcome to our webinar with Dr. Elaine Ingham from Soil Food Web Incorporated and Environment Celebration Institute. We're here to talk about soil ecology, the soil food web, and how to become a soil consultant, how to apply these techniques into your fields. Just a little bit of introduction. My name is Vivian Kalouxilos. I'm up in Quebec, Canada, and I am a soil food web advisor who's gone through the training of Dr. Elaine Ingham. And I now have my own company here called Docteur. Terre means soil in French, so it's a play on words, it means soil doctor. And I assist market gardeners, farmers, landscapers, and urban growers away from traditional organic and chemical approaches to soil management to incorporate the soil food web perspective. So without further ado, I'm going to let Elaine introduce herself. 1 second, actually. Before I let Elaine introduce herself, I do want to let you all know that at the end of this webinar, we will be offering a special discount link to Elaine's 4 courses. The first one being Life in the Soils class, which is all of the theory which explains how biology can drive the chemistry and physics in the soil, how the soil food web can passively feed our plants, suppress diseases, restore water, and sequester carbon, all of these lovely things. The second course is the compost class, where we go through all of the theory and technicalities of making high quality aerobic composts that have the whole food web present. The third course is a compost tea course, where we go through all of the theory and the technicalities to do with creating very high quality compost teas and extracts. And the fourth course is the microscopy. So how do you know when you're making good stuff? How can you see the microbes? You got to use a microscope. This is not easy for everyone to do. It's not something we're all used to doing and growing up with. But with this class and with the help of the webinars, you are able to identify the organisms that are there and be able to assess the improvement of your soil, identify disease-causing organisms, and whatever else you'd like to do with it. So without any further ado, I'm going to let Elaine set up her slides, and when she's ready, she will take over the discussion.
Yeah, I'm having, there we go, share screen. But now I don't have my slides up there, so.
I can tell on the left-hand side.
Okay.
I did the screen share.
Yeah, you're fine. You can go ahead and pull up your slides, Elaine. We can see your screen. So
Okay.
go to the bottom.
Where has that gone? So let me know if that came up. Did that come up?
Yep, we can see it if you want to make it full screen.
Yep.
Yeah.
Alrighty.
Should be good to go. All right.
The joys of electronics, hey? Amazing that this all works. Though some of us who are a little bit not computer savvy, it gets to be, woo, fun. Okay, so Vivian has explained the special offer at the end, and we'll go through that again at the end of today's session, because we want you to understand how you can take on this whole way of doing things yourself. And you have choices, of course. You can do it just for yourself. You can apply this knowledge to just your garden, to just your window boxes, to just small pots, or you can do it to, you can apply this approach to growing any kind of plant that you want to think about. Maybe we don't know everything about every plant yet, but we're certainly seeing that this approach benefits the growth of any of our plants, going back to working with nature instead of having that kind of arrogant human attitude that we know better than nature. We have a better understanding of how the world works, and we can ignore nature. We do that at our own peril. We need to understand how nature has set up things how it's supposed to work, and then work with that instead of against that. Because of course, in a war between nature and human beings, who's going to win that one? It may take nature a while to, finally win out, but ultimately that's the path we're trying to tread right now, where we're constantly taking the nuke it approach, as I say it. We're constantly killing things. Oh no, that thing shouldn't be there, so I'm going to kill it. Well, you can't kill just that one thing. You're killing a massive number of beneficials when you go after the problem organism, the disease, the pest, whatever. So how do we work with nature? How has nature approached this problem of dealing with the pests and the parasites and the pathogens? Well, all those pests and parasites and pathogens are only viewed as bad organisms from a human point of view, not from nature's point of view. All those organisms are doing something exactly as nature has set the system up. They're doing their job exactly like human beings should be doing their jobs. So we need to understand that natural system and work within it. And so hopefully today we'll go over a short explanation, show you a couple of examples of kind of the before and after situation, and go into that. How do you develop this knowledge? How do you get all of the details of what is necessary for you to be able to manage and apply this approach? This first slide, how do we recover from this? This is what we human beings have done to every agricultural area that we've come into, started to do agriculture on larger and larger scales. And this is just an example from the American Great Plains of what we did to the soil. We allowed it to blow off, and it's mostly in the Atlantic Ocean at this point. When you're looking at this picture, the person sitting up in the grass area, that's what used to be the level of the soil in the Great Plains in the United States. And the person standing over on the left side is showing how much of that soil we've lost because of inappropriate practices. When we first come into any agricultural system, we start to till, and tillage, of course, starts to slice and dice and crush and destroy the very organisms that build that soil in the first place. And as we lose those organisms, of course, we don't lose them all with the first tillage event. We only lose maybe 50%. And then the next time you come and till, you lose another 50%. And the next time you till, and the next time, until finally you have nothing to hold your soil in place. You cannot build structure. Compaction starts to occur. And then the wind blows, or water moves across this landscape and starts to wash the dirt away, because this does not happen until you convert that soil into dirt. Dirt being, of course, just the mineral components in the soil. So when I'm talking about the organisms, this is a picture of that set of organisms. And sorry, someone, full screen. This is full screen. Sorry, this is the best I can do in terms of the whole screen. Mine doesn't, if I click, see, that's not that. This is full screen. Sorry, guys.
Okay, great. Thanks, Elaine.
So this is the soil food web. So the different organisms in this picture are the important critters to get back into your dirt. So, there's the sun up in that upper left-hand corner providing energy to the plants. And of course, the way plants store energy is in the carbon chains. And that's really what we mean by organic, is that we have chains of carbon storing that sunlight energy. And of course, when it's just a simple carbon chain, that's a sugar. So your plant then needs all of the nutrients that it can get from the soil. And so your plant will pump those sugars down into the root system in order to pick up the nitrogen, the phosphorus, the sulfur, the magnesium, calcium, all of those mineral nutrients from the soil. So how did Mother Nature figure out how to make those nutrients available? Because all of those mineral nutrients are present in our soils. That's where plants have always gotten those mineral nutrients, all of them. The only thing your plant gets from above ground is sunlight and carbon dioxide, which there's your carbon to form those chains. Everything else is stored in the soil in a mineral form. So in the crystalline structure of the parent material, and then the parent material, when it breaks down, and it is the microorganisms that do most of that work now that we have organisms on this planet. Before organisms, it was just simple sand, silt, and clay. It was just simple weathering processes that broke down that rock into the rocks, the pebbles, the boulders, the sand, the silt, the clay. Now it is the microorganisms, the bacteria and fungi, that are the most important role in breaking down the parent material into the different size fractions. And then that is the crystalline material that is holding all the mineral nutrients. Every second of every day, your rocks, your pebbles are breaking down into sand, silt, and clay. So that's like an infinity process until this planet loses the bones of mineral rock material. We don't really have to worry about a source of nutrients for our plants. But in that crystalline structure, in your sand, your silt, your clays, your rocks, your pebbles, etc., those mineral nutrients are not available to your plant. And so you have to have the bacteria and the fungi. So here we go. I'm circling the bacteria. Hopefully you all can see my pointer there. And there's the fungi. They make the enzymes to pull those nutrients, nitrogen, phosphorus, sulfur, magnesium, calcium, sodium, potassium, iron, zinc, all of those things, pull them out of the crystalline structure of the sands, the silts, the clays, the rocks, the pebbles, and pull those nutrients into their bodies. How do the bacteria and fungi get the energy to do that work? Well, the plant is putting out exudates. The plant puts out the sugars, the proteins, the carbohydrates, cakes and cookies, if you will, because that's what that's a recipe for. Your plant's putting out the cakes and cookies, but very specific ones to feed the bacteria and fungi and make those nutrients available to the bacteria and fungi. And of course, most of the bacteria and fungi are around the root systems. But once those nutrients, it's like an intermediate step. Your plant is putting those nutrients stored in the bacteria and fungi into the pantry right around its root system. And of course, then that will attract in those things that eat bacteria and fungi. The protozoa eat bacteria. Just follow the little arrows. Who eats who? Bacterial-feeding nematodes eat bacteria. Fungal-feeding nematodes eat fungi. Fungal-feeding microarthropods eat fungi. And whenever one of these predators eat their prey, that releases nutrients in a plant-available form. So when you start to realize that function, there is no need for inorganic fertilizers. There's not even a need for organic fertilizers. Other than the organic material is adding food to feed bacteria and fungi and make certain that these microorganisms will survive and continue to do this nutrient cycling job if there's no plants present. But if we have no plants and no organic matter, those bacteria and fungi are going to die. There's not enough energy, there's not enough food to get them to do their work. And now fallow fields where we have been convinced that we have to leave soil with no plants on it in order to store water. What causes water storage in your soil? It's the structure built by the bacteria and fungi. If you want all the little pores, all those places that water will fill up, so that when your roots go down into the soil, they will find a source of water. you have to have this food web present. You have to have this food web present so that your roots can move through the spaces in that soil, the pore structures, the air passageways, the hallways, to allow water to infiltrate normally and to allow roots to grow into that soil normally. Or you're going to have problems keeping your plants alive through that dry summer period. So we have to have this structure. When we go back to the Great Plains of the United States and you start looking at where's the compaction layer in this picture, you can see the soil, the original soil surface, but look at where the really massive compaction is. That's at the depth that the plows went down to. The plowing, the tillage, causes compaction where the plowshare presses down and it compacts that soil. Water from rainfall or snowmelt moving into that soil will not go from soil of one structure, one texture, into soil of a different texture. So water hangs up here and then washes off. The root systems can't break through that compaction layer if it's over 300 pounds per square inch pressure. So your roots can't go as deep as they should. The roots can't get down to that summer water that they need, and the whole system blows away. We destroy our own ability to grow the food that we need to have. How are you going to grow plants, grow animals, if you don't have the plants? So we have to get this whole food web in here. And part of what we teach you is all the information that you need to understand the role and function of the good guys and, of course, the bad guys. Root-feeding nematodes, are they really necessary? Don't we want to just completely destroy and wipe root-feeding nematodes off the face of this planet? No, because the root-feeding nematodes serve a purpose. We want to make sure that the root-feeding nematodes are attacking your weeds. They're attacking the plants that don't belong there. And so when you really think about it, if you've got root-feeding nematodes attacking your crop plant, the plants you want, that's Mother Nature saying to you, your crop plants don't belong here. This is not a healthy situation for them. They will not do well. And Mother Nature is sending the root-feeding nematodes to get rid of the sick, unhealthy, unhappy plants. If you eat food from a sick, unhealthy, unhappy plant, what nutrition are you getting? You can't possibly be getting the nutrition that you require. Your animals can't be getting those nutrients. So we need to set this system back up. If you've been tilling, you were told to do that, and you did it with the best of intentions. Unfortunately, if you don't know what you're doing and what the effect of what you're doing has, the road to hell is paved with good intentions. So we need to understand first. And so taking these courses allows you to understand the role and function of each of these organism groups. When you're growing corn, what is the set of microorganisms that you need in that soil to make certain that the corn is the one that's healthy and happy, and that the weeds in the system are getting wiped out by the root-feeding nematodes, by the disease-causing fungi, by the disease-causing bacteria, by all the things that will attack and consume the sick, the unhealthy, the unhappy, and get rid of your weeds. So you don't have to be putting on herbicides. That's a totally unnecessary thing. When you think about cover plants in your soil, we've been told to put seeds in every year. Annual plants, you've got a cost of that seed every year to put in that cover plant, and then you kind of have to hope that the season is right and that cover plant comes up, and then comes springtime where you've got this massive above ground plant material, because that's what the agronomists are telling you you have to do. You've got to grow all of the soil, the organic matter that will go back into the soil in order to feed the bacteria, fungi, protozoa, nematodes, all these organisms in your soil. Except, how do you get that above ground plant material back into so how do you turn it into soil? What is that process? Well, you have to have the microorganisms. So if you're going out and mowing down that cover crop, you're compacting soil. that cover crop is sitting on top of the soil, and very often, because you've got so much wonderful growth above ground, that organic matter is going to go anaerobic and kill the very organisms that should be decomposing that material and turning it back into soil. If you till that organic matter, what did you just do to the biology in the soil? You just reduce that by a good 50%. So we're going half a step forward and 3 steps backwards if we don't understand what we're doing. So instead of an annual cover crop, what should you be putting in? You should be growing a permanent, low-growing cover plant that will remain in your system forever. When you go to put your crop in, you just go down, open up a furrow and drop your seeds in that furrow, and your seeds will pop up in half the time. Seeds germinate much more rapidly when they're in a friendly environment. They're getting the nutrients that they need. They're getting the protection from the diseases and pests. So understanding this whole system is what we want to make certain that you come to understand. As I've very briefly described, a healthy food web, the right sets of microorganisms for your plant, are going to deal with all the pests, all the diseases, the pathogens, the problem organisms, because you're going to set up this healthy functioning food web around the root system of the plants you want to grow. And so they compete with, inhibit, consume those problem organisms, and they're not a large part of your system anymore, but you have to inoculate those. You've got to put them back into your system. And so we help you understand how to grow your own microorganisms in your conditions with your waste material, and then inoculate that back out into your field. When you do this process, you only have to develop that inoculum and keep making that inoculum, that addition of really good organisms, for maybe a year. Most of the time, if you're really following directions, you're putting out the organisms into your soil, and pretty soon you get them there and you're feeding them. You've got the permanent understory plant in there that's constantly going to be feeding your microorganisms. And as soon as the soil warms up and those plants start to grow again, food's going into the soil to feed these microorganisms that are only too happy to grow and protect and help your crop plant when you finally put it in your system. All summer long, they feed that biology in the soil. Their root systems go as deep as your crop plant, and they're making certain the right mycorrhizal fungi are colonizing the root systems of your crop plant. And of course, because that mycorrhizal network is maintained all year long, every year for the next, I don't know, several hundred years. As soon as you drop your seed into that soil of your crop plant, it's getting connected with that below ground system, and all those plants share nutrients. When we get the mycorrhizal fungi established below ground, all plants that require that particular food web, all of them are going to be healthy and happy. None of your weeds can compete. None of your weeds can deal with that problem. In the trials that we've been doing in Oregon and California, where we have a farm now, and so the experimental fields are being put in, we showed last year that in the half of the field where we did not add biology, we bought a farm that was only dirt. There was no soil on the property that we could, in the agricultural area. So no added biology. How long did it take us to weed a 10-foot section of that field? It took us an hour and 55 minutes because there were so many weeds that had come up in a 2-week period of time where we did not weed. And now we went in and we timed how long it took to take out every weed. As compared to 5 feet away, a row where we had added biology and put in these cover plants, it took us 5 minutes because there were only 2 weeds in that system. No need to be spending money on herbicides. No need to be spending your time applying that and subjecting yourself to toxic chemicals that ultimately will kill you just as much as they will kill the bacteria and the fungi, protozoa, nematodes, all the beneficial things in your soil. We want to hold the nutrients in your soil, and so with the, the picture of that soil from the Great Plains back in the Depression in the Dust Bowl era, we want to retain nutrients so they don't leach, they don't run off, they don't blow away, they stay in the system. Every grain of sand that you lose is enough nutrient to be growing an acre of your plants. If you would somehow get all of the nutrient out of that grain of sand, Mother Nature will do it. Give her long enough. The microorganisms are going to be pulling all the nutrients out of that grain of sand, and that crystallized material will be released in all of its mineral glory. It's going to take a while. And so as long as we have sand, silt, clay, rocks, pebbles, or organic matter in our soil meaning we've got to have the biology, there is really no worry. So making the nutrients available to your plant, that's a function of the bacteria and fungi being eaten by protozoa and nematodes. If you don't really understand how that works, take the classes. Explain that very carefully, very step by step. Here's what has to happen. If you've got toxic material, if your soil has gone anaerobic and all those horrible toxic materials are being made in your soil that will kill your roots and kill your beneficial biology, how do you decompose them? How do you build soil structure? Who's responsible? So I've touched on that just a little bit, hopefully enough to intrigue you and make you realize that that's a lot about soil you don't understand. So when we're looking at dirt, over on the left-hand side, dirt is just the sand, the silt, the clay, the rocks. The spacing on this has gotten a little messed up. Soil is the mineral content and the organic matter and the aerobic organisms. So that has gotten a little bit messed up, so I'll move on. So of course, if you take the online courses, you'll get to see that slide in its correct format and hopefully the backup information to allow you to understand in detail exactly what you need to know to get the kind of effect that's being demonstrated in this slide. This is some work that we did with Harrington's Organics, and I'm hoping in the next webinar that Todd will come on and he will talk about the process of converting Governor's Island from rubble into ecosystems that are growing beautifully, and exactly what is that process. So hopefully the next webinar, which is in May, we'll have a couple of the Soil Food Web advisors that have already been out there working and demonstrating that what I'm talking about works, and it's way less expensive to do that approach. So in this is Boston suburb, and people often that are into large agriculture or growing gardens or something, they're like, what do I care about this? Because these are plants, and you can look at that lawn as being a pasture. The processes that we're going to do here to take the neighbors, when you look at all of the neighbors' lawn, this is in late September, midway September, so in September to go, Boston. Summer has been kind of hard on all the plants. It's been a drought. They have not been able to water their lawns. So all the lawns, except for this one, are dry and brown and sere. And the only green plants growing in that lawn, of course, are the weeds. Whereas what happened here? What, did these guys manage to escape the police with the tickets? Nope. Absolutely no water has been applied to this lawn, to this yard, during the whole growing season. So they stopped applying watering the lawn in the fall of the previous year. So through this drought, they have not had to apply any water because these root systems are going deep. These root systems are down at 5 to 10 to 15 feet, getting to that summer water that's been stored. These plants aren't, because the root systems on these plants in the neighbor's yard are only going down 1/8 of an inch, 2 inches, if you're lucky. So how can these plants, how can these grasses stay green and vibrant and healthy when there are no root systems because of the compaction that's been imposed, because of the lack of biology building the structure that has to be there to allow those root systems to go down? Notice that none of the plants in the plus biology yard are sick. None of them are unhealthy. We've brought the proper biology around the root systems of the trees and the shrubs up to what it needs to be, fungal dominated. In the grass, we want it equal biomass of fungi to bacteria. In the garden in the back, you want it actually bacterial, but you must have some fungi. You have to have enough to bring everything back to this condition of health where it's good to eat that food. This food tastes wonderful. Go across the street, and every single one of these trees over here have bare, denuded, insect damaged portions of the plant. Every single one is showing signs of disease. That is not a healthy shrub. Well, it's just getting brown and sere because fall is coming. Well, then explain that nice, healthy plant in the yard with biology. Still green, still vibrant, still actually showing some reproductive activity. So we want to enable you to take your yard and convert it from this weed wasteland into a healthy, vibrant, working year-round, always building structure, always with healthy plants, and so you can grow your own healthy food. Another example, this comes from Australia, where I've worked with Tony Evans and Nick Routson. Camper Down Compost. They had started a composting operation where they were getting paunch from a slaughter facility, and they wanted all of the growers around them, mostly dairy people, to bring in their waste materials. They would compost them, and then they figured they would sell that compost back to the dairy people, but it didn't work because the transportation costs were too high to take the manure, transport it to the composting yard, and then later in the year come back, pick up that material and transport it back. It just wasn't economic. So the issues that the growers were dealing with were this whole list here. The fertilizer costs are going up every year. So how do you pencil that in? How much is the cost going to increase on a year-to-year basis? And if you're paying more for the fertilizer than you're getting for the crop that you're producing, for the milk that you're selling, you're not going to stay in business very long. Insect problems, well, those are our pathogens, our pests, our problem organisms. When those insects are attacking the grasses, in the case of these pasture systems, then you got to go out and what should you be doing? You should be fixing the biology in the soil, on the surfaces of the grasses, bringing that grass back into a condition of health instead of using pesticides. In a war of Mother Nature sending pests to deal with the problems versus you and that pesticide, ultimately, who's going to win? Nature. Can she send meaner and nastier and more horrific pests every year? Sure she can. So stop fighting nature. Start working with her. The grasses were being pulled out by the animals. They had to resow paddocks every year to the tune of $20,000 per field. You are not going to keep your farm very long if you have to be replanting several fields every year. And it had gone from maybe on occasion resowing a paddock, a pasture, to every year having one, then every year having two, every year having three, every year. See where we're going? Path to hell is paved with good intentions. So total devastation is going to be happening here, and the growers could see it, and they were just getting sick to their hearts. They went into the business of dairy farming to have animals, to take care of them, to have these friends that they could interact and work with, and all of the animals were sick. They were unhealthy. The smell, is just horrific coming from their manure. They were told by the agronomy community to dig a big hole and put the manure in there. And by the time that pit filled up, then they would have other recommendations for what to do with that manure. So that's what they did. They built a pit that has been from the dairy yard where they bring the animals before they go into the milking parlor. From the milking parlor itself, they're washing out the manure and putting it into these pits. And they actually have a second pit here that's filling up. There actually is another pit over here that isn't included in this picture. So imagine the flies, imagine the disease, imagine all the toxic chemicals. Would you want to live downwind from this? So that's why people hate dairy farms, is because, oh, gosh, I just start thinking about losing breakfast when I look at this. So they take the water from these manure pits and use that to water their pastures. This water is so high in salts, particularly nitrate, that it's killing the biology in the soil. It's killing the grass. So what are they supposed to do? What can they do instead of this? So what we had them do was take all of that manure out of those pits, turn it into compost. So we taught them how to compost correctly. They couldn't afford the turners, so the composting operation brought the turners out. And so there are routes where every springtime, they're going to make some compost. Every fall, they make some compost, so that all of their manure is being used up. They've been able to close the pits because they don't need them anymore. They make compost. And now they're spreading compost made on their own property with the indigenous sets of microorganisms at very high diversity, because now they've been doing this a couple of years. They're increasing the diversity of the organisms. So no matter what weather conditions occur, they've got the biology to deal with nutrient cycling under all of those different conditions, whether it's wet, whether it's dry, whether it's cold, whether it's hot. No matter what combination, the biology is present in their soils to deal with these problems. So here's one of the farms that we started out working with, Andrew Whiting. And his pasture, when he first put out the proper set of biology, i.e. we made compost on his property, had the good sets of organisms in it, he went out and spread this at 1.5 tons per acre. So this is not like 10 tons, 100 tons. No. You don't want to be putting that much. If you put on a couple inches of manure, you're going to kill everything in the soil, and the manure itself causes the anaerobic conditions that grow the diseases, the pests, the problem organisms. So a light dusting is what goes on here. And look at what happened. Look at the clover coming up. Andrew said since the time he had bought the farm till here, he had never seen clover growing in his pastures. Of course, his agronomist said, oh no, clover causes bloat in the animals. No bloat at all in Andrew's herd. Now the neighbors putting on massive amounts of urea and phosphate and sulfate and other nutrients, he had bloat, serious problems. The veterinarian was over at his dairy all the time. Basically, Andrew had no visits by the vet that he had to pay for. The veterinarian would stop by and say, I haven't seen your herd. What's going on? And Andrew would explain. And the vet would walk away just kind of bemused that this could be possible, that clover would not cause bloat. What causes bloat? It's nitrates in the plant material. If you put too much nitrate out there, the plant's got to get rid of it, and it puts it away in its own biomass, and then your animal eats that, and it's going to cause huge damage, huge problems. So there's, in the first applications of the compost going out into the field. So look at that pasture. Wouldn't you love to have that pasture if you're a dairy person, or running cattle, or running horses, goats, sheep, whatever? And they were looking then at how far down had the root system gone. After just a couple applications of the proper biology, and now that's luscious. This pasture had been grazed 10 days previous to this picture, so it'd been grazed down to the grasses had been a good 4 to 6 inches tall. When they finished grazing, Look at how much that grass has grown in the 10 days. And that's what healthy soil will do for you. You will have this kind of plant production. Don't really care if it's grass or clover or corn or beans or beets or whatever. The work that we're doing at the farm in California is showing that where we have biology, and that's the only thing we've added as compared to not adding the biology, we will increase plant yields by a minimum of 300% in one growing season. So as we look, well, there were some of the plants that we were growing that we had increases of 1,120% increase in yield plus biology as compared to no. So we're seeing exactly the same thing. So going through, here they are digging down into the soil. They want to see how far down the root systems are going. And lo and behold, they find nodules on those root systems. They've never seen nodules on the root system of the clover because, of course, if you're putting inorganic fertilizer out, that prevents the rhizobium from being able to form on the root systems of these plants that should fix nitrogen. No nodules on your root systems, no nitrogen fixation. The clover in other pastures where they're putting on all these inorganic fertilizers, they were just green plants causing problems actually. Here, these plants are actually fixing nitrogen, but the nitrogen they fix is not put into nitrate, it's put into protein. Why would a rhizobium, why would a bacterium fix nitrogen? Not to release nitrate out into the soil, they make protein. The plant is contributing sugar, the nitrogen fixing nodule is converting that into the nitrogen gas into protein. So that the nodule grows bigger. Look at the nodules. When we start looking at there, see, that's what a nodule should look like. It should be marble size, not some wimpy little teeny tiny teardrop thing. There's a teardrop nodule. It's just getting started. But with time, that should get bigger and bigger and bigger. When you cut it open, it should have a pink color inside. Look at the color of those nodules. They're kind of even pink when you look at them before you cut them open. Nitrogen is being fixed. Look at how deep that root system is growing. Here's one of the helpers at Andrew's farm. He's holding that the grass and the clover at his hip, and it's touching the ground. In one growing season, that's how much deeper the root systems of your plants will start to grow. And if your root systems are growing down that far, do you have to even consider or think about fertilizer? If those root systems are growing down that deep, they're getting to water. As the season proceeds and they get less and less water, those root systems just go deeper and deeper, finding the water that should be stored there as long as the biology has made the structure so that that water can be stored. If you don't have any dams, if you don't have any lakes or rivers or streams, how can you hold on to your water? We got to rebuild it. So let's get that done. No nitrogen has been applied on that pasture, and this is 10 days after the last grazing. You can put animals out here again. A comparison with a neighbor. So think of this as the before on the left-hand side, and here's the after, adding the proper biology. And look at the difference. The neighbor had to re-sow this pasture in the last year because it was pretty much bare soil. So he's re-sown. And look at how poorly. This is springtime because this is Australia. Of course, December is springtime in the southern hemisphere. So that grass is barely taking off, as opposed to look at the right side of the fence with the biology being added. So look at the fact that the biology is trying to sneak under the fence and go west, young man, young microbe, go over there. There's all those empty habitats. You can establish a family over there. So the western frontier. So let's take a look at a series of pictures of this interaction. Now, this picture was taken looking up the hill. So the next picture, of course, they turned around and took the picture down the hill. So try to learn to take pictures at exactly the same spot and in exactly the same direction. Always try to have pictures of something in the distance that shows that this picture is exactly the same place as the one you're going to take in a month or 2 months or 3 months. We're showing the success. So here, this is in April. So this is late in the summer period, after a lack of rain coming down. When you look out over these pastures, which pastures belong to the whitings? Which pastures belong to the neighbors? They have not grazed that pasture more than once. And it wasn't the full herd. It was just the sick, pregnant cows that were put on this pasture. This had the full 300 and some odd animals that the whitings had in here grazing. This has been grazed 5 times during this growing season. So between December and April, there have been 4 grazing periods, because of course there was one before I showed you that last picture. As we go, here we are in May. So a month later, this has now been grazed 2 more times. Still not grazed. In that, so through the whole growing season, only 1 grazing. Is that grower getting the benefit? Absolutely not. So he's mowed some of these pastures, and look at the weeds. You're seeing the weed patches. Look at Andrews. There are no weeds. So documenting these kinds of results, that's, as you learn this system, as you learn how to do this, and you do it all basically on your own materials. You don't have to go out and buy a lot of stuff, depending on how large your acreage is. Can you just buy a couple of shovels and a pitchfork and basically be able to do this system? Do you have to go out and buy a windrow, a turner to do windrow turning? Depends on the acreage, but of course at large scale, you have to have the equipment to allow you to do that work. So think of all the benefits. They don't have to resow the pastures. The cows are not pulling the grass out by the roots, so you don't ever have the bare soil condition that requires resowing. They're backing off on the nitrogen. Usually in the first year, we got people off their nitrogen inputs completely. We would always say, if you kind of have to have the safety blanket, you please put on half the nitrogen that you would have applied based on, like your agronomist comes and says you need 600 pounds per square inch or 600 pounds per acre of nitrogen fertilizer. Back off. You do not need that much nitrogen fertilizer. In the first year, have it, just so you feel confident that your plants are going to still grow. And then you realize that much nitrogen really probably was not used, not necessary. So in the second year, if you're still like, go to 150. And then pretty soon you realize that was a waste of your time and money to buy it or put it out. The wastes, say goodbye to the manures. You compost it, and then it becomes something worth its weight in platinum. You put it out and look at the benefits. No diseases, no insect pests. The cow fertility, they had better calving. They didn't have the problems. They didn't have to call the vet and get the help. And you want to validate that with every year. Stocking rate increased, mycorrhizal fungi increased, and so that whole below ground network starts working. All of the pasture is healthy, or all the pasture is sick. Which do you want to be putting your animals on? So, some of the growers have been putting out hormones to try to force the grass to grow. Right, force the grass to grow. How healthy is that grass going to be? Animals don't get the nutrients that they require. And so they saw their bricks, the percent solids in the plant, increased from 1 to 2 back when they're putting on the hormone to force the growth of the grass. Stop using that, put on the proper biology, and their bricks went up to 11 to 13. I've actually seen in these pastures where it's gone up to 18. So your animals are eating that grass. Is there any need for a supplement? Absolutely none. So another example, probably the last one that I'll go over, and then we're going to go into more of what is the procedure, how do you become a soil food web advisor? How do you do like Vivian, where she set up her own business? And I think I can probably speak for Vivian and say she's so busy.
Yeah.
She needs help, but she needs help from people who have been properly trained. All over the world, we've got people that want to employ our services, and we've got a waiting list of those people. So we need to have folks who are interested in this, take the classes, learn what you're doing, do a conversion process where you take dirt and turn it back into soil, and you document the benefit. So like with Ian Smith, here we are in Tasmania. His problems, so here's what you usually have to think about with a grower. What are their problems? Well, weeds. Yeah, that was the end all and be all of his existence, was getting rid of these weeds. Well, there were some insect problems, but not high on his list of problems. Yeah, he had fertility issues. And he said, well, no, I really don't have fertility issues. And I said, so how do you solve those fertility? Why are you saying you don't really have them? So you sort of have them, but you don't really have them? And he said, well, because I put out inorganic fertilizers. And that always makes me laugh. You have fertility problems, or you wouldn't be putting out the inorganic fertilizers. You're fighting Mother Nature when you do that. And so, of course, you've got these other problems. When you put out inorganic fertilizers, you're setting the stage for weeds. Stop doing that. Why have you been convinced that that works so well? Well, when I put out the inorganic fertilizers, all the plants grow better. That's Mother Nature telling you there's something really wrong. You're trying to grow plants on dirt. You need soil. If you have the proper biology, you put out an inorganic fertilizer and it will not make any difference at all to the growth of your plants because they don't need it. Stop spending your money doing that. And of course, when you're tilling in inorganic fertilizers, you're compacting your soil and setting the stage for weeds, because weeds don't put their root systems down that far. Because weeds, their major purpose in life is to suck nutrients out of the soil, suck water out of the soil, make a whole bunch of seeds, and then the next generation is with us in another 2 weeks. So how do you stop all of that? It's basically, so here's one of their pastures, or one of their fields. I always enjoy this picture because it takes you a while to find the onions in this picture. There's a row of onion going straight. Wow. And then you start looking to the sides, and are there onions out there? You can't really see them. You can see the weeds though. No problem seeing the weeds. And this is his chemical pastures, or chemical fields, sorry, paddocks, when we're in Australia. So he's going to have to go out and he's going to have to put another application of herbicide out here in order to deal with those weeds and try to get the onions to grow. And we started digging up some of the little onion plants to see what was going on with their root systems. So we'll be looking at that in a minute. Now compare this to the 150 acres of field where we applied the proper biology. And do you want to say that we applied 2 applications of proper biology before the onions went in, and then we applied proper biology with the onions when they went into the ground. And these are seed onions. These aren't sets. Doesn't really make a difference, whatever stage you want to start out with. And so here we are looking at the field where we have applied the proper biology. It has become established, and that's one thing we want you to always do, is do the microscope work to make certain that the biology has taken. Just because you threw something out there does not mean that it's going to take. You throw seeds out, and none of the seeds ever germinate, ever grow, ever do their things. So yeah, see, Mother Nature doesn't know what she's doing, because I put seeds out there and they didn't grow. Right. That wasn't soil. That was dirt. So we have to get the seeds in the right place. We have to give it the right biology, and they will respond. These onions planted on exactly the same day as in this field. Look at how much bigger these onions are. They're going to go to market way earlier with the onions from this field. They will get first of the season prices on their onions. And so, of course, they're going to make a lot more money here. Plus, they don't have to be putting out fertilizers. They don't have to pay for that. They don't have to pay for the herbicides. So they don't have to apply that. They just all the things that accumulate when you get the biology out there. You know, the whole field was healthy. So, you know, just looking at all of the different views. Notice that one strip here, they did not put any biology on this strip. Look at the weeds. That is what the proper biology is suppressing in the rest of the field. You know, so people wanted to say, well, you picked a field that didn't have much weeds. Really? This is what that field would have looked like. Would you have gotten any onion yield out of a field that had that much problem? What you're looking at here is the onion, and you're seeing that onion come up. So this is the chemical field. Look at the structure in that soil. There's no structure. Now think about a drop of water falling on the surface of that soil. It would run off. It would not infiltrate. So of course, here's the little onion. And look at that root system. It's only going down 2-3 inches. Look at all the weeds. Look at all the competition coming up. This soil, this dirt, is meant to grow weeds, not to grow onions. We've got to shift that. We've got to get this soil looking like this. Good structure, good biology, building airways and passageways so that water, air, and roots. Notice that we had to back off taking this picture because the root system on this onion is going down 12 inches to 15 inches, depending on exactly which seedling that we chose to dig up. Look at the structure. Infiltration is going to be great. Oxygen moving down there is going to be great. When you put out a compost extract or a compost tea to continue to build that food web, it's going to move right into the soil and start doing its job. So, you know, he didn't have to use the herbicide. He did count herbicide applications that he did before the compost was put out, before the compost tea was put out. But for this crop, no herbicides were used at all in the biological side. So that's what we want you to do. We want you to document. So here's an example of organisms in the original agricultural field, and you can see the values for total bacterial biomass, total fungal biomass, which soil has adequate fungi to grow your row crop. Well, this is nowhere close. What we want is equal biomass of bacteria and fungi where we're growing row crops, for example. So how are you going to improve that total fungal biomass? How do you get it up to where you're going to grow healthy corn or wheat or barley or oats or whatever, or grasses of any kind? You've got to add something. And the simplest, easiest thing to do is at 1 ton per acre, apply the compost, a bare dusting. Make sure it gets into the soil, so water it in, or make sure you're putting it in a time of year where you're getting some rainfall. And in that compost, you can see we had a hefty amount, good amount of fungi. So within 2 weeks, look at how much that fungal biomass has come up. It's growing. It's going to continue to grow. So monitor and make sure that that fungal biomass comes up to where you need it to be. When you're looking at the protozoa in that original agricultural field, it was totally compacted. Ciliates are the anaerobic form. Yeah, they're cycling nutrients, but your roots can't grow in an anaerobic soil, so it's not doing your plants much good. So what we want to improve are the aerobic protozoa that eat the aerobic bacteria and will provide nutrients to your root system. So how do we take it from 0? Nobody home doing this job, only the bad guys doing the job. How do we convert it to really good protozoan numbers? Well, we better have those protozoa in our compost. We apply it and look at 2 weeks later. Yeah, we lost a few. They didn't all survive the journey, but enough survived. So these organisms will continue to grow. We're going from bacterial diversity that's laughable. You don't have the organisms that are going to function every second of every day. You've got to increase them. So get the compost out there with massive diversity of both your bacteria and your fungi and your protozoa. So hopefully, some of these kind of brief overviews of what we do, that before and after kind of picture with just a little bit of explanation of what exactly did we do to move things along. You can see that it's slightly different in different situations depending on the plant that you're trying to grow. So you have to understand the requirements of your plant. This is part of that knowledge base that has to be imparted. And so the first thing we want you to do is take the online soil food web courses. And Vivian's going to come back on in just a few minutes and go through that special offer. Because if you sign up now, you can get these courses for an incredible discount. Whereas if you wait till later, the offer is going to be gone. The online courses, and of course, Vivian went through, it's the life in the soil where you get the basic theory behind the soil food web. You get connection to the scientific literature that shows other people are doing this work, not just me. So there's a whole network of us scientists at different universities. And of course, we're scientists, a good quarter of the agronomy, agricultural community poo-poos everything we do, say it's absolutely can't be done, not possible. They're non-scientific, blah, blah, blah. But of course, several thousand publications by all these different people doing this work now. I just happened to be out there on the forefront. I worked with a group of people on the forefront, so we were doing this documentation, and it's always fun to go back and look at the history of that. But online courses, you take those first. So it's life in the soil, then it's compost, how to make good compost, the many different ways to make good compost, then compost extract and compost tea, and then the microscope course. So you can do all your own testing. You don't have to send samples off to a laboratory and wait for them to get things done. Your lab report comes back 3 weeks later, which is a little bit beyond the time that you needed it. You needed that information today. So you know what to do. What's the recipe for my compost pile? What's the recipe to make my extract or my tea? When should I be putting it out? Do I have the organisms in my inoculum that I need to add to my fields? So you got to be testing your fields. So once you get the courses done, and we do require that you get a 90% correct on the quizzes. Everything is open book. We don't say you have to close your book. You know that you've got those reference materials. You've got the transcripts from the course. So you can go back and search and look, and we're expecting that you will do that. So of course you're going to get better than 90% on those quizzes.
Can I add, Elaine?
Yep, sure.
Yeah, going through these classes, it's really great because it's self-paced. You can rewatch them as many times as you want. You have the videos of Elaine teaching. You also get all of the slides, and it's all written down. Everything is transcribed. So if you wanted to recheck something, but you don't have access to the internet, but you've downloaded the transcripts, you can read your course. You can even download the MP3 of her talking about each course. So after you take the class, you have access to all this for a year, but you can download all of this information, the slides, the transcripts, and the MP3, so that you always have it. And it's really, a lot of people are asking in this thread, like, where do we get the organisms? What can I use? What's good for an orchard? What's good for lavender? How do I monitor? All of this and more is covered. I'm realizing my camera, there we go, you can't see me. Yeah, so all of this is covered in these 4 courses. And there are webinars as well that you sign up to. So as you take the courses on your own pace, there are scheduled live webinars with Elaine. where you pre-submit your questions that you might have had during, you know, the course on nutrient cycling or whatever it was, and it's kind of your way of getting access to questions and getting through to Elaine. There's also a private Facebook group where all of us past and present students are part of, and we keep in touch. We help each other. You know, if there's an organism that we are looking at and we have just no clue what it is, we can post it there and get help. If you're
and you can always send the picture to me, and I usually go, "Ooh, that's an incatriid."
Yeah.
I identify it for you. There are some things that we don't spend a lot of time on, and so sometimes you do have questions, and so there's always this support system available to you. And Vivian is very important in that support system. So she's right here as kind of one of the right-hand people for me to deal with all of the questions and all of the information that we're working with. So after you do the online courses, then this is the part of the process of hands-on. We want you to actually do this work first, because I've seen that people take the online courses, they do a good job on taking the quizzes, and they pass with flying colors, and then they go out and they don't use this knowledge. So we've seen that we've really got to require that you practice this, so you really understand how much easier this is to do. So we want you to make compost so that you develop the biology, the bacteria, the fungi, the good guys, the aerobic guys, the aerobic protozoa, the good guy nematodes, hopefully some microarthropods in there as well. You learn how to do that. Why is it that the disease causers, the pathogens, the pests, the parasites, why aren't they present in your compost? Because of the specific things we do. The heat in a thermal composting pile, passage through an earthworm's digestive system, or contact with the outside of an earthworm, those are going to be removing, making certain that the pathogens, the pests, and the parasites are not part of that compost. And then there's your set of microorganisms. But it is a bit tricky to put all the information together, because you have to be monitoring temperature and time and turning, actinobacteria presence, anaerobic conditions. There's a number of factors. So the course on compost answers all of those kinds of questions for you, very practical. How do you do this? What is a green starting material versus a high nitrogen versus a woody, and who are you feeding when you do? So all that wonderful stuff in the compost course. And then once you've got good compost with the good sets of organisms in it, we want you to extract those organisms into the water and apply that and show that you've gotten them transferred, those organisms transferred into the soil. And so there's the next step in becoming an advisor, is to actually do that. So you have that practical experience and you know how to be successful. And then with the compost tea, same thing, make a compost tea where not only you extract the organisms into the water from your compost, but you add foods to make bacteria grow. If that's what your soil needs, is more bacteria, then you want to make a tea that is going to up the bacteria. Most of the time we see that soil is, dirt is extremely anaerobic bacteria. You don't need more of that. So we need to be selecting for, in our compost teas, the aerobic bacteria and the fungi and the protozoa and the nematodes. So you're extracting those from the compost. You're adding fungal foods so that the fungi will grow, so that the fungal feeding nematodes will be able to increase in your soil as well. So we want to go through that process and make sure you understand how to make a really good compost tea. And then we ask that you choose a place, your garden in the back part of your suburban lot, or a flower bed or whatever plant you want to grow. We ask that you choose a field or a paddock or a whatever, and convert that dirt back into soil. So we're requiring that you understand what dirt is instead of soil. And so you document that you're starting with dirt. You see what's missing, you see what's lacking. So now you know you've got to have a compost with the missing organisms in it. And then you need to design the steps in applying that biology, which of course we go over time and time and time again in the Life in the Soil course, in the compost tea, compost extract. And the fourth course being the microscope course. I forgot to stick that in there. A microscope course, so you learn how to identify all these organisms. Many people find that they need a lot of practice with the microscope. They've got to intensively work on the microscope for a week or two to get really comfortable. So we do offer additional courses at the farm in California, or Vivian can work with you, or Todd Harrington, or Molly Haviland, or any one of the existing soil food web advisors or consultants. So bringing you into this system is what's going to happen, into this network. And then, of course, we want you in your certification program to document every step that you did and monitor what the biology was doing, and then show success. You've got to decide what success means. Typically for me, it means that there's no disease, there are no weeds, there are no insect pests. All of those problems have been dealt with because you got the proper biology in there to protect your plant, to help your plant do this building of the soil. And so your yields are higher, your fruit tastes better. We're trying to work with people that are doing nutrient density to add in that assessment of the food that's being produced. It's just really difficult sometimes to decide what nutrient is going to be measured. When we're looking at nutrient density, you cannot look at just total nitrogen or total calcium or total phosphorus, because if any of those mineral elements are present as minerals, you can't take those up across your digestive system. You've got to have them in an organic form. It's got to be in the correct form for you to be able to take up those nutrients, or for your animals to be able to take up those nutrients. So looking at total nitrogen is just ridiculous. Nitrate is not one of those things we should be consuming. If you start eating a lot of nitrate, you're going to end up with cancer. So exactly the opposite effect. And so total nitrogen is not a useful measure. So figuring out exactly what we need to be measuring and coming up with a simple way to do that measurement. So we're in the midst of all of that with this nutrient density determinations. And so we're going to be adding that aspect to determining success. So you could use that simple, easy process of determining nutrient density instead of paying several $100 to $1,000 per sample to assess diversity. So with that, I'm going to turn it back over to Vivian to finish up talking about the process of becoming a soil food web advisor and getting you started on all of this, which I hope we have convinced you that it's totally possible we can do this within a single growing year. You will see the effects of improving your biology in the soil and reducing your costs.
Yeah, well, great job, Elaine. People in the chat seem very engaged, very excited. I am one of the mentors that helps to assist those who are going through the certification process. And like Elaine explained, you go through the 4 courses and they invite those who achieve a 90% average to become a consultant. Now, if you're taking the courses because You want to understand soil better, or you're a farmer or you're a market gardener. You don't necessarily want to be a consultant. You just want to know what's up, then you don't have to worry about that. But the 90% average is not hard to get if you are really paying attention. Like we said, it's an open book quiz. So once you go through all that, you sign up to become a consultant, to go through your certification training. And a certification training, you've got to create 3 compost piles that have, you know, all of the food web present, that have the minimum biomass or numbers of organisms present in the compost, depending on what you're trying to do. So you make the 3 piles and the 3 teas and the 3 extracts in your project. You know, I did a project. One of my projects I did this summer was with a very simple, with a landscape company who wanted to improve their organic lawn care service. And so I went in and I chose 15 of the 76 lawns that we were going to treat in Ottawa, which is the Canadian capital. 15 lawns that were representative of kind of all of the lawns types that we were finding. And I took all of the biology data at the beginning. There was nothing going on in these soils. There were barely
it was dirt. It was dirt.
It was like dust coming up. I would go to take my sample and all of the soil would fall out of my sample core as I was pulling it out of the ground. Very, very dead. The grass roots that were already there were not even an inch into the soil. So on some of the lawns we sodded, some of them we seeded, and basically we put top dressing of compost, and we did a depth treatment of compost tea, and we did a soil drench of the surface with a compost tea. And in some cases we sodded, some cases we seeded, and by the end of the summer, this summer was a huge drought. And you could see that it was like the example Elaine showed. Everyone had brown grass, dust all along the street. And our lawns, which weren't even irrigated, they had just received composts and compost tea. They were green, dark, dark, dark green. And just in one season, we got the average roots went down about 7 inches. And then some of the roots went all the way down to 9 inches just in one growing season. And I mean,
in the middle of a drought.
In the middle of a drought. I just love this example because it almost seems like it's too simple. It almost feels like you're not really doing much. You're like, oh, well, I'm spreading compost and I'm spreading compost tea. But when you see these results, it's just, you know, you can't deny that it works. It really works.
And you know why it works.
And
with a lot of kind of magic elixirs, you're putting things on, paying a lot of money for it, but you don't really understand why that's working. And if you don't understand why something works, it's really hard to use it again in the right way and put it on at the appropriate time. So we really want you to understand why this approach works. You're putting the biology back. Make certain that you've got all the biology that you need.
Yeah, and it's really cool for those of you who also study permaculture, biodynamics, agroforestry. These are, and if you don't, you should get into them because the soil works in symbiosis with the plants. So the plants are doing photosynthesis. They're creating these sugars that we call exudates, and this is all in Elaine's classes. The plant sweats it out through its root system and all around its foliage, and it is attracting the microbes it needs. So it's putting the microbes in the soil, and it's also keeping them alive, and it's really the connection between the soil and the plants. It's very empowering to understand, you know, why permaculture principles are this way. Why do we use brown mulches for perennials and green mulches for annuals? All of this stuff just makes sense. Someone had a question before, you know, I make cheese and I throw the leftover liquid from my cheese onto my plants and then they grow. Well, yeah, they probably have lots of great bacillus in there. So understanding, you know, why these things work.
The whey is a food resource for microorganisms, and as long as it stays aerobic, then it's going to be beneficial organisms. But you put on something that is slightly anaerobic into an anaerobic system, and you can kill all of your plants. So if you don't know what you're doing, you can end up with the results that are devastating, as opposed to it could have worked really well if you knew what you were doing.
And it's interesting because I've received compost samples from all across Canada at this point, and you'd be surprised how many compost companies don't realize that they just don't have much going on in their compost. And sometimes it's a simple thing that they are, they're screening their compost too many times. So the first time before they screened their compost, it was amazing. And then they put it through a screen process once, whoop, we see a 50% decline. And some people go through a second time, and then we see 75% less biology. So just understanding these details to be able to find, sometimes it's the tiniest little adjustment that needs to be made in order to really see things kick off. Peter submitted a question that's interesting. What are some of the jobs that Soil Food Web advisors get? And are they through Elaine's established program? Does it carry credibility outside of Elaine's network? I started off by getting jobs through Elaine. She was getting jobs in, Canada, and she's too far away. She's in the west coast of the United States, and she was getting jobs on the east coast in Canada. So as a trained consultant, she passed them over to me, and that's a part of what got my ball rolling. But for me also, I'm engaged in my local agroecology and permaculture network, and people in this whole scene and in the market gardening scene really are loving this. So by giving cheap workshops, I actually started getting a lot of clientele like that. And now it's just
cheap?
Well,
Inexpensive.
Inexpensive. Yes, sorry. Wrong use. Very valuable, but accessible. Introduction courses to kind of build the network. We need education in order to build the economy. So that's kind of how I've been doing it. And I haven't put up a website yet. I haven't put out any advertisements. And so far, having the support of Elaine, and also this word of mouth through my local network has gotten me plenty of work, more than I can keep up with, to be honest.
Yeah. And you need help. We need help. We have people all over the world that are starting to use this kind of approach. So we have a project going on in India. We have people just contacted me from Brazil, one of the largest acreages in a single farm in Brazil. So we'll be going down and working with that. A project coming along in France, South Africa, Indonesia, Philippines, Japan. So, all over, as well as, the United States. I've always thought of the U.S. as being like pesticide central. So, of course, we have to concentrate a lot of effort here to really convert pesticide central into biology central. And we need more people to help us do this. So as you go through the program and you pass the classes, you start making your own compost, local indigenous organisms that are most beneficial for your area. You could start selling that compost if you want to make money. You can sell the teas, you can sell the extracts, and then you start working with people on their own property. And so there's a consulting fee that you get for that. We are certifying people, so you don't have the Soil Food Web blessings until you finish the certification. And I think you probably really want to finish that certification before you really go out and start consulting. And of course, we're always here as backup to help you when you're working with people and you run into a problem, or this is a situation you've never seen before. How do you deal with it? I probably have dealt with it before. So this network is really important. When you finish, and I didn't forgot to put this up there. When you finish with your project, now you've got an example of converting dirt into soil, and we would like to have your data, your before, during, and after pictures, your determinations of success to put up as a story on our website. We have a few examples of success stories, mostly because most of us are so busy we don't have time to put a nice finished product together, but they'll be coming along. There'll be more and more of them going up. But your success story would go up there. And so then our website and all of the people who come to our website on a daily basis will, when they're looking for an advisor, a consultant nearby, close to them, they'll of course go to, state, province, country, whatever. They'll find your success story. And then of course their natural reaction is going to be, here's someone who's already done it. I'm going to pick their brains. I'm going to find out how to do this most rapidly in the most efficient, least expensive way. And so they hire you. And that's exactly what's happened with Vivian and the other soil food web advisors who have started their own businesses and are being entirely successful. It's a lot of work, but I think it's a very satisfying kind of work.
Absolutely. Being a soil consultant, I have a background in ecology from the School of Environment at McGill University, and I did ecological field work for the Smithsonian Tropical Research Institute, and I did lots of applied permaculture, lots of applied agroecology and organic farming, and lots of volunteering before I ever stepped in feeling comfortable. So you're going to do what you have to do to feel comfortable, but practice makes perfect. And this network of support that is offered through Elaine is definitely worth it if you feel that you have what it takes. And, being a soil consultant is one thing, but then being an entrepreneur is another. So when you start your businesses, this is the reality. Entrepreneurship is a skill that I've had to foster over time. I'm still not there. I'm a fantastic soil consultant, but being an entrepreneur has been a challenge for me. So this is, you guys might have different setups. You might have partners you work with. You might have a brother or a sister who's very good at business that you can team up with. You get creative. You can do it your own way. Every year, starting this year, we had our first consultants conference where Elaine invited the advisors right now that are working in the field. Some people have been doing this for 30 years. So it's really amazing to connect with these people that have all kinds of experience. And once you are certified, I highly suggest you go to one of these events. And if you are certified and you're doing well, you would be invited, because connecting with people and to see, that there's other people who have been doing this, they've been doing it for 30 years and they made it work. But everybody has a different business model. But so anyways, this isn't a business webinar. This is about life in the soil. So we'll get back to that.
Yeah, setting up your own business is always a challenge. So that's why I always work with people who do the business end of it, because I'm a research scientist and I want to keep working on understanding why the biology works so well and exactly how we're going to get that biology back into the soil in the most rapid, least painful, least expensive way, that we're making sure the plant we want to have grow in this system is going to be the one that the biology in the soil selects for. Let the biology wipe out the weeds. Great. That's what Mother Nature's there for. Make certain that you've got the biology that will promote the plant that you want. And so going through the courses is going to do that work for you. So how about, I think, the exclusive offer. You want to explain that, Vivian?
Yeah, so here is the bit.ly. Mark Capola just put it in the chat as well. You can go and find it. This is it also, if you want to copy that and put it in your search bar, and it'll bring you to the discount link. We also are going to send you this email this link by email, and you're going to get the PDFs of the slides, so it's all there. But essentially, you click on this link and it'll bring you to lifeinthesoilcourses.com, and there's a special discount offered to you guys, the attendees of the webinar only, for the next 5 days. So you've got 5 days to use this discount of 50%. We are offering 50% off the courses, so it's actually a huge help. And Elaine and Caroline and the others that run Environment Celebration Institute understand the world of finances, or lack thereof of finances, but we really do need more people working on the soils. We firmly believe that this is one of the most important things we can be doing today, aside from being a great person, to really help alleviate, de-escalate the situation that we're all collectively living on this planet.
If we really want to solve global climate change, if we want to put the carbon dioxide, the elevated carbon dioxide in our atmosphere back into the soil from whence that carbon dioxide came, we've got to put organic matter. We've got to build that organic matter. And it's just laughable to me when I listen to agronomists and they say it takes 100 years to build an inch of soil. Are they? Well, they don't understand soil. They don't understand life. Because if you give me the proper starting materials, I can basically build soil overnight. We've got to put the organisms back in there and make sure that they're functioning. And they immediately go into the processes that nature intended them to do. They've got to do their job, and they do it. So we can instantaneously rebuild soil, start building the structure, getting the disease suppression, getting nutrient cycling going again immediately, if you understand what you're doing. So to put that carbon back into the soil, we also have to realize that it's not going to go back into the soil just in the top 2 or 3 inches. How far down does soil go? How far down do we find sand, silt, clay, rocks, pebbles, organic matter, and all of the food web organisms? We can go as far as you want to go down. So, most people think of soil as only going a couple of inches. Well, no, we're talking as far down as the root systems of your plants ought to be going. The root systems of your productive grasses should be going 12, 15, 25 feet, not inches, feet. When we're looking at good, healthy shrubs, those root systems should be going down 25, 30, maybe 50 feet, depending on the shrub. When we're looking at trees, deciduous trees easily have their root systems down at 100 feet, as long as the soil structure is being built for them by the biology. When we're looking at conifers, those root systems can go down 250 feet. They could go deeper. Nobody's gone down there looking, but when we're dealing with cave systems, we find active, living, growing roots of plants. And they, of course, have to have the biology associated with them. So how far down into the soil surface can we store carbon in the form of organic matter that is not going to turn over, not going to be released as CO2 anytime in the next couple thousand years? You want to sequester soil, sequester carbon dioxide? That's what we have to do. If we all started doing this, if we all started converting our dirt back into soil, we could very reasonably take all of that elevated carbon dioxide in the atmosphere and put it back into soil such that we didn't have elevated carbon dioxide in the atmosphere in 1 year, 1 growing season. If all over the world we did this, we could deal with that problem this summer. If it was just North America, it would take, say, 3 years. If it was just the North American continent that followed these practices. What if it was just Quebec that did this? Well, it's going to take a little longer. But it's entirely reasonable to think that we could do this in a very short period of time. And we better start doing this because that, the going over the edge is not that far away. So we really need to train people and really need to get this workforce out there doing these conversions of dirt back into soil as rapidly as possible. So, Vivian, you're going to go through each of the classes then, right?
Yeah, sorry, I thought I was unmuted, but I totally wasn't. Yes, so Life in the Soil class is basically all of the theory that goes through soil food web science to explain how does the biology affect the chemistry and the physics of the soil? How does this work? How do we get the microbes? How do we get the whole food web going? How does the soil do nutrient cycling? How does the soil sequester carbon? How does the soil create fresh drinking water and fight drought and diseases? So this is very much the theory, the big understanding of this perspective of soil science, the Life in the Soil class. It is the longest class out of all of them. These classes are self-paced. I believe you have 1 year to complete them once you pay for them. Yep. So that is the Life in the Soil class. We go over, basically why healthy living soil is a good thing. And
we do a number of examples in there as well.
Lots of case studies.
There's, some practicality in it as well, but we start out going into depth of the fact that chemistry is not what drives plant production, it's biology. Biology controls chemistry. It's not the other way around. Chemistry does not control the biology. Mother Nature just puts a different organism in there. And it's the organisms that are in charge, really. It's your plant that's in charge.
Yeah, so this course essentially helps you understand how Mother Nature designed the relationship between plants and soils. The other courses are, so there's the compost course, which goes through everything from A to Z to different compost systems, different production methods, different recipes. So what kind of compost do you want? Maybe you want a heavily fungal dominated compost because you are treating orchards. Maybe you want a slightly bacterial compost because you are putting it in your vegetable gardens. So how do you manipulate the microorganisms to give the balance to food web at the end of your compost pile that you need for whichever ecosystem you're trying to implement it to? And by the way, in the Life in the Soil class, we do go over, okay, well, how do we figure out what lavender needs, or what corn needs, or what my hazelnut trees need? All of this is also in the Life in the Soils class, because you need to understand the theory of why is it at the beginning of ecosystem succession there is no fungi, and by the end, when we get to old growth forests, it is completely fungally dominated soil ecosystems, from 100 to 2,000 times more fungal than bacterial. Why is it that in mid-succession at prairie grass systems we see an equal 1-to-1 fungal ratio? So you will understand and you will know what food web you need to create for whichever ecosystem you're trying to put it into. There's the compost tea class. There's lots of technicalities that come with making good compost tea. Compost extracts are a little bit less complicated than making compost teas. We also go through the difference between compost tea and extract, and when you would want to use either extract or tea. And how do you make it? Which ingredients would you put in to kind of grow the biology you need? So, for example, I have to treat an orchard which needs at least a 5 to 10-to-1 fungal dominance over the bacteria, but my compost is only 2 times more fungal than bacterial. So I need to grow the fungi in my tea in order to bring the fungal ratio up to at least 5-to-1, which is where the tree needs, in order to spray it out. So how do I do that? Oh, well, this is how you do it with compost teas. And you want to grow fungi? Well, this is the kind of ingredients you would put in, etc. And then there's the microscope course. how do you know if you have good organisms in your soil? Well, one, you can clearly see if your soil is sick or disease infested, pest infested. You'll know if it's low productive. You'll see if there's weeds going out of control, but more particularly, okay, I've got a disease, but what exactly is going on in the soil around my tree's root system or your plant's root system? This is when microscopy comes in hand. How do you know you're making good compost teas? This is when microscopy comes in hand as well. How do you know you made good compost? How do you know that your treatments are even making a good impact on your soil? Well, you need to learn how to monitor these processes by doing proper microscopy and proper methods building when you're designing soil treatments. So you can buy all 4 courses, or you can get just the 3 courses. So this is the discount for all 4 courses that Elaine has pointed to here, which is the original value of $5,000 US to $2,495. So you're saving a good 50%. It's a risk-free investment, so 100% money-back guarantee if you've taken all these courses and you've learned nothing, and I don't really know what else to say about this, because I I don't think it's possible that it could happen. If you found this webinar informative, these classes are going to blow your mind. There's just, the information just keeps coming. So I guess we've reached a little bit of a Q&A here with Elaine. We had some good questions. One from Kim. Elaine, she said, I've been told that in Southeast US, it's hard to keep organic matter in the soil because it just burns up due to our humid conditions. Is this true? I do notice that compost and manure do break down incredibly fast. Is there a difference? Is there a different management required for humid climates?
I've done a lot of work in the tropics, so I spent a lot of time in Hawaii and Central America, Colombia, very tropical, Australia, South Africa, and really no, the organic matter layer doesn't have to decompose very rapidly, but when you're putting out mulch or you're putting out some organic material or compost, and it seems like just overnight gone, it's because the wrong sets of microorganisms are present in that material. Bacteria grow very rapidly. So a single bacterium in 20 minutes can now become 2 bacteria. Those 2 in 20 minutes will be 4. 4 in 20 minutes will be 16. 16 it will become 84, and then you're into the thousands and the tens of thousands and the hundreds of thousands. If one bacterium grows without any limitation, if perhaps we could have infinity food on this planet, that one single bacterium would reproduce and reproduce, and in 72 hours, something along that line, it would weigh more. The biomass of that one bacterium, after multiplying all that many times, would weigh more than the planet Earth. That's their potential. And of course, if the bacteria are growing that fast, and if it's perfect conditions, got the moisture, got the temperature, got the organic matter, bacteria just take off, and your organic matter, poof, disappears very rapidly. So instead, what we want to make certain is that we're getting those fungal hyphae into the system, because the fungal biomass, those fungal species, are going to take that organic matter and make very complex substrates out of that organic matter. It is that fungal biomass that makes the ulmic acids, the fulvic acids, the humic acids, builds humus. So you need a mix of all those complex, structurally difficult to break down plant materials. So your cellulose has to get converted into these more complex substrates. Your lignin has to get converted into these more complex substrates in order to maintain that organic matter layer in tropical systems where we've got plenty of moisture and constant warmth. The fact is, in tropical systems, like the southeastern part of the United States, you have to have constant plant cover. And if you're not out there putting in the seeds for the plants that you want, the low-growing understory cover plants, if you're not influencing the system in that way, then of course Mother Nature is going to put weeds into that bare soil. Nature does not tolerate bare soil. She will get something growing in it. And if you do nothing to influence the course, then nature's going to start out at the earliest stages of succession and take you up through succession. Because once you disturb soil, once it's not soil but dirt, that's what succession is going to require, starting with the weeds and building over the course of 1,000 years of succession. So let's jumpstart succession. Let's jumpstart immediately to perennial, low-growing plants that will always regrow and cover the soil surface in your pot, in your garden, in your small acreage food production area, into the large pastures, into the ginormous agricultural fields where we grow mile on mile of corn, wheat, barley, soybean, things like that. Make certain that there's always plants feeding the microorganisms in that soil. Then you don't have to be putting down layers of organic matter. You don't continue to have to make large quantities of compost to put down on that soil surface and protect the soil surface. Grow plants that are going to do that work for you so you don't have to work so hard. Does that answer that question?
I think so. Somebody had an interesting question. How do you implement no-till on a potato farm?
There's always going to be some soil disturbance, but you only want to disturb the soil where you're going to put in your seed piece. So whether you're putting them in furrows or you're building hills, there's going to be that disturbance. So if you've got these low-growing cover plants, yep, you're going to go in and you're going to dig out the precise place where you're going to put that seed piece in. So you dig out, you pull up enough of that cover plant material, seed piece goes in, cover it back up, and then that seed piece is going to put out the shoot, and you want it to have enough space cleared. And typically for potato, it's going to be somewhere between 4 and 6 inches surrounding where you put the seed piece in, to allow that potato to, the cotyledons come up, and then the first true leaf, and you want to have that already up above the height of your cover plants. So we're not talking 6 inches or 1 foot, 12-inch cover plants. These are plants that grow only, maybe right prostrate with the soil, or are only going to be 2 to maybe 4 inches tall. With potatoes, because they're going to get quite a bit higher than that, we could probably go 6 inches for that cover plant, but probably safer. And then you just have to know what the spacing is that you want to knock those cover plants back. So you're not ever going to go completely no-till. We're going to keep it down to just the absolute minimum disturbance where you're going to plant your furrow, drop your seeds in. Or if you're doing direct drill, you'll direct drill just in the core, pop the seed in. Yeah, but that's still disturbing the soil. That's, you've got very small points of disturbance. So whichever you want. With a direct drill, you'd probably, if that's the kind of planting that you're doing, you would really want to make certain that your cover plants were quite low. And typically we're going to choose cover plants that can be driven on. So you will never have a problem of getting back into your field, even if it pours for weeks at a time, as it has finally been doing in California. We've had 6 months or 6 years worth of rain in the last 3 months. Oh joy. And lots of problems with erosion in people's fields, lots of places that are having collapse of hillsides. Not on our farm. We have lost no soil. because it's all happily tight in place. The only place that, well, I misspoke a little bit. The only place we've had soil erosion is in the area where we have maintained no biological additions. We've got some problems going on there that we've had to shore up. But where we have the biology, no loss of soil. Everything stayed in place. So no damage from this massive amount of rain that we've had. So we want to get that biology back in there. With tillage, you only till just exactly where you need to open up the space to allow your seed, once it germinates, that has to get up above the canopy of your cover plant. And you want to be able to drive on that plant so you never have problems with waterlogging or puddles or anything like that ever again. You will always be able to get out into your fields. Okay?
Yeah, that's great. Am I muted? No.
Nope, you're on.
I'm on. Okay, that's great. I guess, Elaine, how many more questions do you want to take?
When do you want to end? At 11 or 11:15, something like that?
Yeah, let's take a few more questions.
So another 15 minutes maybe?
So yeah, there's questions about the certification process. This is not a discount for the certification process. This is a discount for the 4 courses.
For the classes.
For the 4 classes. And then once you pass those with your good average, then you apply for the certification process. So just to clarify that.
And we always hook you up with an advisor or a consultant that has had years of experience out in the real world doing these kinds of approaches. So you have a mentor. You have somebody who specifically is assigned to you as that advice giving helper. You may want to come to the farm for a bit of a microscope course or work, say, with Vivian, with that group that she's has put together on identifying the organ, using your microscope to figure out what's in your compost, in your teas, extracts, what's in your dirt, and then making sure that you're converting it to soil.
That's right. Let's see. Any research on? Oh, this is from Jesus. Hi, Jesus. Beautiful name. Any research on how well this works with palm trees, dealing with fungus like fusarium and pink rot?
Yep. The reason why the fusarium or pink rot is causing you problems is you have no competitor fungi in that dirt. And so the fact that you've got, or there are these problems with your palm trees is a very clear indication from Mother Nature. She is trying to tell you, she's telling you in the only language she has to communicate with human beings, that this is dirt and you gotta change that dirt back into soil if you ever want to grow palm trees without these problems. So you need to make a really good fungal dominated compost, and then you would probably want to make something like an extract with that and inject the extract into the area around the palm tree. Typically, we're going to go about 4 inches out from the trunk of the tree and put in 4 injections, going down as deep as you can get it, so hopefully 4 feet, punching through all those compaction layers. And then you want to go out halfway between the drip line of the tree and the stem and put in 8 injection sites, and then go out to the drip line and do 16, as long as it's a big enough tree to do that. And you want to be injecting this really good biology so it will start doing all the benefits we've already talked about. I worked with palm trees in Hawaii on Waikiki Beach, these many years ago. It was probably like 1980 something, where all the palm trees along the beach in Waikiki were dying. And they then got the money to dig up all of those dead and dying palm trees and replace them with young palm trees. Big, huge disturbance. Millions of tourists who were disturbed were not happy about all of this, but they sent us soil samples We looked at that soil and went, this is so compacted. It's horrendous. You've got to get in there and break up that compaction, get oxygen back down to the root system so the palm can put their root systems in as deep as possible. And of course, the agronomists, the soils people looking at that said we were crazy. This is sand. You can't compact sand. And I said, oh, really? Want to bet? Because of course it was compacted. I happened to be out in Hawaii for working with other clients and at the Ecological Society of America's meetings, and was standing at the edge of that excavation site when they brought in the big front end loaders to dig out the area around the palm trees preparatory to pulling them out of the ground. They got down at 18 inches, and the small size shovels that they had just would impact on that surface, that horribly compacted surface at 18 inches, and they could not dig it up. It was impossible. The contractors wanted to know who had poured the layer of concrete at 18 inches. They were adamant that that was a sidewalk down there. And no, that was compacted sand. So they had to get big, the really giant size, where they pound and break up that compaction. They had to go get those really big size pieces of equipment to break that up, get that compacted material out of there. And of course, they didn't finish it in one day. They all went home. The next day they came back, and the palm tree that they had finally broken up all that compaction from around its root system was already putting out green leaves. All they had to do was get rid of the compaction. They didn't have to dig those trees up. They just had to make sure the habitat was now correct. The soil was right to be allow those trees to grow. But of course, the city had already paid for all of the palm trees, and the company wanted to earn the money so they could get paid, and they dug them up anyway and put in the new trees. And then my attitude was, you're going to have to be putting the proper biology into this sand, because what's going to happen around those trees with all those tourists walking by? They're just going to recompact the soil with all of the vehicles you let out there on the beach. That's all compacting down there at 4 feet, 3 feet, 18 inches. You're just going to repeat this all over again in another 20, 30 years. So go take a look at the palms along Waikiki, and you can see exactly what's happening now. So compaction, we've got to make certain that we deal with that, and you have the proper tools to deal with these kinds of problems.
Okay, so we're going to take one last question and then wrap up. There were a lot of people asking about effective microorganisms and Korean natural farming solutions. What your take is on it, on these products. Also, I've been mentioning localized microbes tend to be better than ones bought from around the world, but we'll let Elaine handle this.
Yep. So it's a kind of a two-part question. So first of all, natural Korean farming has some extremely good ideas, but they don't explain why they work. So, something that they're doing in Korea under those conditions may not work willy-nilly, and in fact won't work willy-nilly in other parts of the world. It's appropriate for Korea and for the climate and the habitat that they have. Now you try to take those methods and transfer them to the desert Southwest or to the cold New England winters and Canada, and not going to be very successful. So, in Korean natural farming, they're taking rice balls and putting them out in the forest. What organisms grow in rice? That's a very limited set of food resources. So you take rice and you put that out into the middle of a forest in Pennsylvania. And what biology in the forest in Pennsylvania has the least conception of how to use that particular structured rice, that starch material? What you're going to get growing on that rice ball in Pennsylvania is going to be completely different from what grows in a system right where rice is very common, and it's a very normal plant, even growing in natural systems. So you're not going to be able to select for the really beneficial organisms that you want. You need to be putting out a different kind of substrate. And actually, it's probably just easier to go out into the forest and collect small amounts of really good fungi that you can see with your eyeballs. Bring that back, put it into your compost pile, and get that diversity of the beneficials that are local, indigenous. They already grow and thrive very well under your conditions. But now let's say somebody from Iowa came to Pennsylvania and said, "Ooh, look at all the really good fungi you've got. Can I take an inoculum of this?" And they take it back to Iowa. How many of those really good fungi from Pennsylvania are going to be growing in Iowa? Not that many of them. You've got to be selecting the things that Mother Nature has already adapted for your own systems. So something that's, it's like biodynamics developed in Germany, works really well in the European condition, but maybe needs to be tweaked quite a bit to make it work really well. You need to understand the biology. So these different systems of doing non-toxic plant production are trying to get at these methods for enhancing your biology, but they don't have the science. They don't have a basis. Are they really, those methods, do they really support the proper biology under these wildly different conditions that we have in different parts of the world? And the answer is probably not. The theory is correct. The principles might be there, but the actual way you do this under a hot dry versus a cold wet or any combination in between is not going to lead you to success. So that's why I would like to have you learn how to be measuring your own biology so that you know you are going the right direction with whatever manipulation methods you're actually using, whether you choose to biodynamic or organic or permaculture or Korean natural farming, whatever. Make sure that the methods that you're doing actually will lead you to success. So we can all be successful every time. So EM, where does that come from? So this is work by a professor in Japan, Dr. Higa, who noticed that when when your average everyday person made bokashi or made kimchi or made any one of these fermented, cabbage is usually what was used in Japan. You take salted water, immerse your cabbage in that water, seal it up and bury it for a period of time until the smell is correct. It's going to ferment. It's going to go anaerobic. And that's why you bury it in the soil, because the smell is like, oh, yeah, I think you're going to throw up right here. So EM, then they would let that finish fermenting. Now, when that cabbage is fermented and turned into, well, it's what we call sauerkraut in the United States, fermented cabbage. You're going to take that out. You're going to open it up. You're going to eat the cabbage. But what happens with the liqueur, the liquid that's left? People would throw that out onto the fields, and they would throw it in with their vegetables that they were growing, because they would notice that any root rots on their vegetables would be reduced. And so the disease on those plants was wiped out. And so Dr. Higa wanted to understand what was going on and looked at the liqueur, looked at the effects, say, with clubroot, common disease, microbial disease on the root systems of different kinds of brassicas, for example, and noticed that the roots would recover. The liqueur carried microorganisms that would alter the conditions from totally anaerobic around the root systems of those plants. And so the disease-causing microorganisms could not survive. They were killed. They were wiped out. And So he recommended making these mixtures of lots of different species of lactobacillus, some species of yeasts. Usually it had to have a sulfur purple photosynthetic cyanobacteria was another one of the bacteria that he said has to be present in order for this to work. So a whole group, a consortium of microorganisms, and you can grow that by taking a bucket, putting plant material, filling up your bucket halfway, maybe 3/4 full with plant material, covering that plant material with water, and you put a small amount of this inoculum of the lactobacillus yeasts, the photosynthetic cyanobacteria, and they'll happily grow in that reduced oxygen condition. You have to mix it every once in a while. Do it with a stick, not your hand, or your hand's going to smell to high heaven for the next several days. And then you take the liquid from that and you apply it out in your field to reduce these disease-causing organisms. Well, what are you really doing to the biology in that soil? What's the real result? You're putting out a pesticide. You're putting out something that is meant to kill the pathogen, and in doing so, you're going to be killing a bunch of other things, many of which are beneficial. So yeah, you're selecting against the disease, you're altering the conditions in the root system of your plants, but you're not bringing it all the way to aerobic. You're still in those reduced oxygen conditions. Those bacteria require, the lactobacillus, the yeasts, the cyanobacteria requires, or that cyanobacteria requires those reduced oxygen conditions. So you're improving things, going one step forward, but how many steps might you be going backward? So this is not going to solve the problem for the rest of forever. I am way more interested in solving that problem forever. So you never have that disease. You never have dirt in your agricultural system. You always have soil. So understanding what you're doing, and is this really the end goal that you want to reach, or are you only pulling yourselves out of dire conditions into only slightly dire conditions? I'm way more interested in fixing the problem and fixing it permanently so you don't have to work so hard. So I don't have to work so hard. I am the world's laziest gardener, the laziest agronomist that you want to ever come across, because I'm always figuring out ways to get the microorganisms to do the work for me. Let them do the work. They're who Mother Nature has assigned to the role of doing all these good things, growing plants for our consumption. Our job is just to make sure the organisms are there. So we need a way to look at them, measure them, determine whether they are there. And if they're not, then how are we putting them back? Make your own compost. If you really, truly cannot deal with making your own compost teas and extracts, then you want to find a company, find a business that is making the compost and the extracts and the teas. But the way you have to figure out that that company is doing a good job is to look at those materials with your own microscope. Time and again, gone to composting companies and asked whether they have all the microorganisms in their compost. Is this really good compost? And they go, oh yes, oh yeah, absolutely. We've got all the soil food web organisms in there. Really? Okay. I've got my microscope in the car. Can I take a look at this? And there's nothing but anaerobic bacteria in there. And it's, look, put your eyeballs on the microscope and take a look at what's actually in this putrefied organic matter that you promised me had all the right microorganisms in it. You just can't always trust people, I'm sure you've all noticed that. So you've got to be checking up on folks when they're trying to sell you a product. You have to know that you have the organisms. So many people out there have bought, with the best of intentions, they've bought something that they were promised that this was really good compost. They did not bother to say, well, how do you know? Prove it to me. Show me the organisms in this compost if you say that all of the organisms are there. And they get home, they put the compost out, and it kills all their plants. And so they say, see, this biological approach doesn't work. I tried it. It doesn't work. There have been professors at universities who have done exactly the same thing. They've come and listened to my talks. They leave, they go out, they grab what they call compost, which is not compost. It's slightly aged manure. You cannot make good compost out of manure and only manure. That's not possible. You cannot get the diversity of organisms that you require. It is going to be anaerobic. And they take that manure, stick it in a bucket, and make a compost tea out of it. So they throw it in a bucket, they stir it for 5 minutes this way, reverse, 5 minutes the other for a whole entire hour. And then they leave that bucket after they've added some molasses and they've put a little bit of maybe fish hydrolysate into it, leave that bucket sitting with no aeration in their kitchen overnight. And they come out the next day, midday, it's been a full 24 hours. They take that. I can't imagine what their kitchen smelled like after they left this sitting there for that long in their kitchen. They take that liquid and they apply it to their cherry trees and they kill their cherry trees. And then they write articles that say, see, compost tea doesn't work. Compost tea is dangerous. Compost tea will kill your plants. They did not make compost tea. Where in the article did they show that they measured the biology that was in they called compost, that was actually putrefied organic matter manure? Where did they demonstrate that they actually measured the biology in the tea that they made? They didn't. So who is not the scientist? If they don't do the proper testing, call themselves scientists at all. Whereas we really want you to be learning how to use this microscope. It's so easy. You take a drop of your compost tea, put it on your microscope slide, put that on the stage, turn the light on, look through, and you go, wow, look at all those fungal hyphae, look at all those protozoa, look at those nematodes zooming by. Yes, this is great stuff. Get that out on your plants right away, now. Or you take a look at that and you go, all I see are ciliates. There's a billion ciliates in here. Do not put that on your plants. Do not put that in the soil around your plants. Go throw that back on the manure pile because it's no biology that you want to have close to the root systems of your plants. So understanding what you're doing is the central core of all of this and the classwork that we ask that you take. It's just that we give you a whole entire year to go back and re-listen and refresh your memory. You've always got the transcripts that you can go flip through. So right there, here's the information. If there's something in the classes or the transcripts that you don't really understand, then you have the opportunity to send back in questions and find out the answer. So with that, I've probably used up all the time that we had. So back over to you, Vivian.
Yeah, that's it. And Elaine, if you want to end your screen share and just wave goodbye to our participants who have been asking to see your face. So there,
Okay.
there she is. So thank you so much, Elaine. Of course, we didn't cover vermicomposting, but vermicompost, static compost, windrows, thermal, all of this stuff is all covered in Elaine's courses.
Yep.
Whatever isn't, you are in Elaine's courses and you have access to Elaine as a professor to ask questions to. So that's very handy. And just that alone is worth the price of the courses. But I'm telling you, your mind is going to be blown.
But you also get access to Vivian and to the other Soil Food Web advisors. So if I'm not available, you've always got someone else who is ever increasing their knowledge. And sometimes it's actually better to ask Vivian questions, especially if you live in anywhere in Canada. It's probably better to ask her the question, especially if it's weather related or it's something that might require knowing what the weather has recently been like, because she'll be able to answer better than I can. So someone local, quite often, is a much better choice. I'm off in India or something, and I have no clue what the weather's been like in the United States or Canada, and so finding someone local. So we just want to get you all connected into this network of people who are all doing the same thing, all being successful in doing this conversion over to soil instead of dirt.
That's right. So if you feel like this is for you, if you want to make healing the earth your profession, then and that resonates with you, then this is definitely the path to go. If you are a farmer that just needs some help, you can write to info@environmentcelebration.com to ask for, who's the nearest advisor near you that could come and help you. Because maybe you're not going to sign up and become a consultant because you already manage your own farm or you already manage your own horticulture business. Well, that's what the consultants are there for too, is to help, these people who are interested in need. If you're in Canada and you want to keep in touch with the Canadian network that I'm trying to build, then you can get a hold of me, vian.kaloxilos@gmail.com. I will put my email and the contact for the school's email in the comment section below. You will all be receiving follow-up emails in the next few days to remind you to use up your 5-day discount. And you will be also receiving a recording of this webinar, a version of the PDFs to watch over as well of this next 5-day period. So you can't, not watch it in 2 weeks. It'll be taken offline. So you've got 5 days to rewatch this, 5 days to think about it, 5 days to get in touch and be like, okay, I'm going all in. So, and with all further ado, I'd like to thank Dr. Elaine Ingham for her time today, getting amazing feedback in the comments. Elaine, we're just so happy and lucky to have you with us, so happy and lucky to have you opening up and sharing what you know and passing it on.
Well, I'm happy and lucky that you're there to help, that we'll build this whole thing together. Everything that's developed, it's all come from the previous scientists who worked on this before, all the work that my colleagues have done in the world of soil ecology. So it's a great network, and you're helping build it. Fantastic. Thank you so much.
It's honestly my pleasure. This is our planet, people, and we can't wait for others, on higher levels of governance to catch on and realize, oh, what you guys are doing makes sense. There's no time to wait. We got to take matters into our own hands, and this is the best way. It's 2017. We've got 7 billion people on the planet. We've got climate change. We've got disease. We've got water. We've got petrol. Whoa! We can't touch the sky, but we do have our feet on the ground. So why not start there? This is planet Earth. So, we are only victims of our own ignorance. We can turn this boat around, but we need more people around the world to stand up and say, I'm going to do my part for the soils, whether you're just a farmer who just decides to switch your practices or whether you become a consultant and help spread this message in your community. So thanks very much, Elaine. And in the comments, I'm writing right now, the info at environmentcelebration.com. So anything concerning payments, anything concerning course signups, any questions, that's who you write to. info@environmentcelebration.com. Okay.
And we do have time payments, and so all of that is the questions to ask Carol, who handles all of the signups and things like that. So all of those kinds of payments systems, she's the one to ask that question to.
And for all of you in Canada who want to help me build a Canadian network of just people who are enthusiasts about bringing the soil back to life, there's my email in the comments, vivian.kelloxilos@gmail.com. Sorry for my long Greek last name. I was born with it. Nothing I can do about it. And
I think someone just asked about what's the cost of the microscope. They run between $250 and $350, depending on the camera
American.
that you buy with it. Yeah, American. Yeah. So it is an investment. So get somebody to give it to you for Christmas. And they usually do have specials throughout the year. And I know they've got a special running right now. The company we recommend, and of course, I don't have stock in the company or anything, so I gain no benefit from recommending them. It's just that they are the least expensive, best microscopes with cameras. It's microscopenet.com. So all one word, microscopenet.com, and you look in their scientific microscopes. And if you want a link, I believe we've got one on the website. So if you go to environmentcelebration.com or soilfoodweb.com, you look on my tab that says microscopes, and it'll give you the link to go right there.
That's right. And of course, in the microscope course, you are pointed to which microscope you need. You're going to need a microscope to take the microscope course. It'll be hard to participate without it. But, you know, as far as microscopes go, this is very inexpensive. Definitely worth it. You clean it once a year, not very much hard to do, and that's it. You're set with the microscope camera. You can even take live videos and photos of what you're seeing in your microscope. It's fun. I hook it up to a projector, so if I'm teaching or if I'm in a classroom, everyone can see what's under the microscope. So that's just amazing for those of you who are in the education side of all of this. So I think we have covered enough of what we can for today. Anything else, please direct your questions to info@environmentcelebration.com or myself, vivian.kelloxilos@gmail.com. You've got 5 days to use your discount. Let's do it. And hopefully, you know, you'll be speaking with Elaine and I later on in the context of you being an enrolled certified student. So super excited for you guys to come on this journey and, you know, step up as citizens of the earth to take care of our earth.
Okay. Thank you very much. And we'll be talking to you soon.
Okay. Thanks, Elaine.
Okay. Ciao.